EV charging is a little more complicated than plugging in a microwave, right? So I want to take a little bit today to talk about uh, what it is. How does EV charging work? How does commercial EV charging work, so that you can have a better understanding as you're looking to put your solution together, right? Because we run into this. There's DC, there's level one, level two. There's all kinds of different things out there that people talk about, and it's important to know some of the basics so that you can make proper decisions when you're looking at implementing an EV charging solution. So let's start with the basics of it, right? We're going to start, kind of make this, I want to start from the very ground up, so to speak, and think about it this way. What the charger does, whether doesn't matter what type of charger it is, it transfers energy from the grid to the battery. So this is the same as, even plugging your mobile phone in, right? Like you plug your phone in, you're taking power from the power grid, converting it into stored power inside your battery. So that's all a charger does, right? And EV charging is the same thing. We're just transferring electrons from the grid and storing them in the battery. Now, there's two ways that occurs. That's under AC current, alternating current, which is your typical household power, right? When you plug things into an outlet, that's on AC power. Then we do DC power, which is, kind of like your little transistor batteries and things like that, right? Those are DC. If we all remember back in grade school, right, learning some of that stuff. But anyway, so you get DC power. So on the AC power side, they have, you have really, people tried to call this level one. I don't even really consider it level one. It's really something that people do at home, but plugging into a 110 outlet is like a level one. That's okay. But for commercial EV charging, you can't really say you have EV charging if you just have 110 outlets, in your parking garage or out in the parking lot. Maybe that's okay for some of your tenants if in an apartment complex, but for most people, when you're not at home, a 110 outlet's not going to work real well. But that's level one. The other side on level two, on AC charging, is level two. So with both of those, level two is at a 240 volt. So it charges faster. Okay. On both of those, when you're doing AC, alternating current charging, the car itself converts converts those electrons into DC and stores them in the battery. So everything on that instance, the inversion of AC current to DC current, is done by the vehicle itself. DC fast chargers are a little bit different. So DC fast chargers, the inversion process of converting AC power to DC power is done by the charger, and the charger then pushes DC current into the battery, which allows it to charge much faster because it bypasses the on-car charging solution. Okay. So that's kind of the basics of how EV charging works. And on the charging side, so now also let's take a quick look at electrical, right? Like I want to do a little primer on electrical side. What's electrical stuff? So in electric, right, we understand, we hear all the terms, and you have voltage, amperage, and wattage. So each of those combine to get what you need. So I want to, if you think about it like this, let's think about, you've got a 5-gallon bucket outside and you've got your garden hose and you want to fill up your 5-gallon bucket. So when you look at that, what's going to determine how fast your bucket fills? Two main things is the pressure, right? The pressure behind that water and the size of the hose. So if you have a 1/2-inch hose and you have 40 pounds of pressure, you're going to get so many gallons per minute out the end of your hose. If you have a 2-inch hose, or if you have a 1/2-inch hose go to a 1-inch hose with the same 40 pounds of pressure, then you're going to get much more water in that same, you're going to get many more gallons per minute out of that hose, right? So electricity works very much the same way when you look at it. So you have voltage, which is your typical outlet is 110. Your dryer, your home oven, that plugs into 240 volt. And then your DC fast chargers in this instance are going to run on 480 volt. So the voltage when you're looking at electric power is similar to that pressure, right? So the harder, faster those electrons gets pushed through. So at 110, they're pushing through a little slower. There's less push on them. At 480, they're pushing through much faster. Okay. Now, the next piece of this is that size of the hose, right? So that's the amperage. So the amperage determines how much of those electrons fit through that hose as it's going, right? So that's based on the draw of the charger. They both combine to give you wattage, which is expressed in the term of kilowatt hours because the wattage is so small. But if you look at your power bill, you pay kilowatt hour. So that's the same as filling the bucket up in a gallon per minute, or like a gas pump, how many gallons per minute it can pump out. This is what the equivalent to that is kilowatts per hour. So if you think about that bucket being a battery in a car, so that bucket, let's say it's an 80 gallon bucket or an 80 kilowatt bucket. If we're put that on a 240 volt charger with 48 amps of power, of amperage, it's going to pump out 11.5 kilowatts in a given hour. So if you have an 80 kilowatt battery that's completely empty, it's going to take you about 8 hours, about a little over 7 hours to fill that battery up on 11.5 kilowatts per hour. Okay. So that's a little bit, just some basics. I wanted to kind of just share that with you. So those two things you can think about. So now, how does EV charging work? We're going to go a little bit deeper. So you have your charging levels, as I mentioned a little bit earlier. So a level 1, again, that's your 110 volt. That's going to put about 3 to 5 miles of range back into the battery. A level 2 at 240 volt is going to put 30 to 50 miles of range back into that battery over an hour of charging. And then your DC fast charging, or what many people may refer to as level 3, you're going to be adding about 300 miles in an hour. So you see, it's like multiples of 10, right? Like it's kind of funny. A 110 outlet, you go up to a level 2, level 3. Each one of those is an order of magnitude more mileage per hour. And it's kind of ironic because the same order of magnitude can often be applied to the cost as well. Like, putting in an outlet might cost you $1,000. Putting in a level 2 charger might cost you $10,000. And putting in a, DC fast charger might cost you $100,000, right? It's not quite that extreme, but it's very similar. But it's kind of funny to think about that. So why I wanted to explain the levels is that matters a lot for a commercial property. Okay, it's really important because we want to match the charge speed, the rate at which these cars, the rate at which we deliver charging to our customers. We want to match that to the dwell time, how long they're going to be on property. So looking at a hotel, we know that the guest is going to be there most likely overnight. They're going to check in, they're going to be there for a good 6 to 10 hours. So we've got plenty of dwell time to fill their battery back up. Same thing when you get to an apartment complex, right? We've got plenty of time to fill that battery back up. Now, when you get into some other things like recreational things, places where maybe somebody's only dwelling for a couple hours, 3 hours, 4 hours, then we want to look at, do we want to up that charging speed to match their dwell time, or do we just simply have some chargers there so that they can catch a small piece of range along the way? So that's the thing there is matching that speed to how how long our people are on our properties so that we can, balance the right cost of charging solution versus what it brings us back in a return. So that's the charging itself. Now, there's more to just a charging system than just the charger. So we have to look at some of the other pieces that fall in around that. And one is controlling who can use them, right? Who can come up and plug into your charger? Who can take your power from you? If I have a hotel, I maybe want to, I at least want to recoup my power cost. And I would like to make sure that that's probably a guest at my hotel. Okay, so I want to do that. At an apartment complex, we absolutely want to make sure that we're recouping the cost there. So we need to make sure who's allowed to use it. If we get into workplace and some retail things, maybe we don't care as much that we are collecting money directly, but we don't want to be letting just anybody drive up and plug into our chargers, right? So we have to pay attention to how we control who can use them. Some other things that fall into the charging solution are your charging fees. How and what kind of fees can you charge people for using them? So typically there's a software component possibly that goes along with these, or maybe you want to use a more simplified system with an RFID card and you just want to charge them a flat fee. But we need to look at that because that's all part of what makes up a commercial EV charging thing, right? Controlling access. How do we charge for it? And those are the two key things we want to look at. Then you want to look at the next part that comes into this that gets a little bit beyond the basic system, but there's a lot of systems out there that get into power management options. So this allows you to add more chargers to, your current existing circuits because it'll balance the use of the power throughout multiple vehicles and not allow you to exceed the amperage that's available for those chargers. So power management is a piece that can come into the charging. And there's other little things that come out along the way, but they're very ancillary to the charging itself. There are things like camera systems, lighting systems, integrations into your employee badges or property management systems so your guest key cards can turn them on, right? So there's a whole lot of different components that are, I should say, features of the actual charging. So what we wanted to really cover today is what that base charging looks like, right? So to wrap everything up, now some basics about the EV charging, the level 2, the level 3. Again, I don't mention level 1 very often because it doesn't fit for most commercial applications. So you're really talking about level 2 and level 3. So when you're getting ready to implement an EV charging solution, you want to make sure you define your goals. What do you really want to accomplish with this? What are your key goals here? Are you just trying to attract new customers? Are you trying to bring as many people as you can in to use your chargers, like at a convenience store? Then we need to look at what we're trying to do. Then we determine our dwell time so that we can develop the proper solution that's going to match the level of charging that you do, the number and types of stations that you install, how you control the access and network these chargers, and all the other little components that may add up to your overall charging solution, like signage and traffic control devices like bumpers, bollards, and painting. So we want to make sure we kind of look at all that. From that, you can then develop, kind of a budget, a projected return on investment, confirm your goals based on that, and then you can start the next phase of digging deeper into design and implementing an EV charging solution at your location. So if you're looking for any additional information on this, ever want any help whatsoever, feel free to reach out to any of our team, sales@stayincharge.com. We are always here to help, share knowledge, and bring you options so that you can make smart decisions when it comes to your commercial EV charging. I hope this helped you learn a little bit more about EV charging, and we'll see you on the next show.